So share your work for this week. We are going to compare two different job offers. And there is an alternate video down here for it. Feel free to check that out. We've got a starting salary of $50,000 for both jobs. One has a fixed raise of $1,700. The other has a percent raise, a relative raise of 3%. So we have a linear change here. We have an exponential change there. And what we want to do is we want to compare these job offers over time and see how they're different, how they're, if they ever line up. And certainly in the first year, they're going to line up, right? 50,000 here, 50,000 there. And we want to know what's the salary after 5 years, what's the salary after 30 years. We want an equation for each of them, and we want to estimate when the jobs would have the same salary. All right. So I'm just going to pick some different numbers, do a similar problem, show how I set it up in a spreadsheet here. All right, so I have different job offers. I have years. So, and really it's years after that I'm counting, right? 1 year later, 2 years later, and so on. So years after we started, because the first year, either job pays $50,000. So years after starting. So we're going to have a 0 year, and then 1 year after starting, 2 years after starting, 3 years after starting, and so on. And then we have the job with the fixed raise. Oops, raise has an E some days. And then we have the job with the percent raise. Percent. Remember, fixed raise, fixed is this constant slope. That's a straight line change. Percent gives that hockey shaped curve to it. So this is the percent raise. All right, so let's start with, how about a $40,000 job for both of these? And then, I'm going to insert a new thing above here. Above for the fixed raise. Let's see, I want to make it a better deal. Let's do the percent raise first. This percent raise, let's go for 5%. What was this problem here? This one was 3%. 5%. We're never going to get a 5% raise in a job. 4%. Okay, so remember, when we have a percent increase like this, we have to do the multiplier. That's the 1 plus. So the formula for this one right here is going to be starting with the 40,000. So I'm just going to type that in, 4123 times parentheses 1 plus 4% as a decimal, 0.04 raised to the power, close your parentheses, raised to the power 1. So that's my percent raise. So I don't want to fill it down yet. So in the first year, after the first year, I'm going to get 4% of 40,000 is $1,600. I'm going to get a $1,600 raise. So let's say the fixed raise, like they know that, and they're going to say, we'll do better than that. How about we give you a $1,800 raise per year? But it's always $1,800. Okay, so for this one right here, that's my slope. So for this one, I start at 40,000 and then I add my slope 1,800 times the number of years that have gone by. So this is like B plus MX is the way I typed it. Okay, and then I don't want to fill it down yet. So in these two cells, I type my formulas. I'm going to highlight those for now. And as long as I have years down here, they'll make that calculation. So if I grab those two formula cells, I can then just kind of fill them down here. It's going to make the calculations. Notice some weird stuff happened there. It's because I got no years there. It treats nothing as a 0. And something weird happened. That should be a, oh, I see what I did. I did this one wrong. Let's delete that and start over. I want to actually type the 40,000 that I'm starting with. Otherwise, my formula is not going to be right. And then add on my 1,800 times the year. The only thing I want to vary is the year. So that's the only cell reference I should see. All right, so here's my starting salary plus my linear increase, my slope. Okay, now fill it down. That's better. Yeah, so this should treat that as a 0 over there. And then I can just fill down the years for ways and see what happens. So for example, I wanted to know about what's going to happen 5 years later, what's going to happen 30 years later. And right, the fixed raise company went out of their way to give a better raise at first than the other company here. So you might say, yeah, that's what I want. But wait, watch this. This is cool. So to fill down the years, I just highlight a few of them and fill them down. And I want to go down to 30. So somewhere down here. And then I can just fill these two down. And let's make those pretty dollars and cents first. Just go back up here. Dollars and cents. And we'll fill those down again. Over the other ones is fine for 30 years. So a couple things to notice. So at first, since the fixed raise was designed to be higher than the percent raise, it looks like that's the better deal. And it's the better deal 1 year later, 2 years later, 3 years later, 4 years later, 5 years later, 6 years later. All of a sudden, they're starting to catch up. They're pretty close right here. Okay, now the numbers, I'm having a hard time tracking these, so I'm going to do a little difference calculation on the side here. Difference. And I'm, if you look down the list, you can see eventually the percent raise is a way better deal than the fixed raise. So I'm going to take that perspective. In my calculation here for the difference, I'm going to take actually, let's do it on the cell above here. We're going to take the percent raise and then subtract the fixed raise salary. And then sure, we'll fill it down, right? So at first, the percent raised is not as good as the fixed raise, right? It's $200 less, $300 less, $400 less. But then all of a sudden, it starts to catch up, and now it's better. Okay, so in this example, now it varies depending on what this was, what that was, and what that was. Those three numbers together are used to predict when one will catch up to the other. And every set of three numbers like that is going to give me a different scenario. It might happen in 5 years, it might happen in 10 years, it might happen in 20 years before they catch up to each other. So I can see they were the same here. And the closest they get to the same here is in the 7 years later, the 8th year. So here we have almost the same right there. But then after that, the percent raise just keeps kicking butt and gives me way better raises over time, right? So this is how much better the percent raise job paid than the fixed raise job. So definitely 30 years later, at the fixed raise, I'm making like 130,000, whereas if I went with the other job, I'm only making 94,000. That's a big difference. 30 years is a long time later, but what's the point? The point is percent raise, exponential growth always beats linear growth eventually. And I just want you to play around with that idea in a spreadsheet. And then you'll share your spreadsheet. So keep in mind when you share a spreadsheet like this, you got to get the shareable link. And you want to make sure it's not restricted. So mine is, double check yours. I want anyone with the link, and then I can submit that link. So I'm going to click done here. I got the link copied. And so in my submission here, I click reply. And then I'm just going to type up some answers to the questions above and include my spreadsheet. So answers, blah, blah, blah. And then I'm going to link to my spreadsheet. So I'm just going to type spreadsheet and then highlight the word spreadsheet and link it with that address I just grabbed. And you got to get the share address. You can't give me the address at the top of the screen. That does not work. Right? And here, again, I'm actually going to type up some answers to these questions right here. If you wrote nicely on paper and you just want to put up a picture of your work too, you can certainly do that. So if you want, you could insert a picture and then upload the picture you took of your written work instead of typing it. That's cool too. Your choice.